Rangi-Kutta. Yoon's method, Rangi-Kutta, Euler method to solve the first order differential equation. So you can verify the result of the first order by using separable or linear, exact, non-exact, or Bernoulli. But yes, we want to show you separable variable because this is very important, the foundation for all other methods in chapter 1. So we will do first quickly 1.2, then we move on to chapter 4. Chapter 4, we will do the Euler. For the Yoons and Rangi-Kutta, you can try by yourself. But I will let you know what is the important thing that you are going to study today. So you must know separable variables equation and how to solve the separable equation. So first we see the theory, but we don't spend time on the general ideas. Slide number 6. The first order, I use a snapshot. The first order differential equation, if you want to use separable variables method, then you must have dy dx left hand side equals to gx hy right hand side. Slide number 6, 1.2. So this is the what we call the form of separable. Dy dx equals to gx hy. So you have to bring gx from right hand side, hy from right hand side to left hand side. The dx can go right hand side. So all of you know this very well. For example, dy dx y squared x e power 3x plus 4y. You make it like this. You do the grouping x e 3x and y squared e power 4y. Then you can bring the y terms left hand side and dx right hand side. But there are some cases where this one is not separable. So if not separable, then this thing can be solved using integrating factor. Integrating factor, because this is linear equation, dy dx minus y cosine. But this one can be solved using Euler method, Yoon's method, Rangi-Kutta. So this one also. So that's why we want to connect chapter 1 and chapter 4 as a revision. Now, how do you separate? So the dy dx equals to gx multiplied by hy. So you must write the separable in this form. Py dx equals to gx dx. So what is py? Py is 1 over hy. So this is the nice form. So no fraction. So we want to write without fraction. So it is just without any fraction. So py dy equals to gx dx. So the terms are no fraction. That means we don't write 1 over hy dy. So we write py dy equals to gx dx. So now you want to solve this. There is a problem here, because when you want to solve this, you must know the integration. So the method here is separable is the form. But separable method, when we say separable method, it involves integration, this step. This is the hardcore. That means the real method to solve the separable. So all these are embedded, you see. So you put integration sign, integration of py dy equals to integration of gx dx. So when you integrate py dy small p, you get big P plus a constant a, because this is indefinite integral. You integrate small gx dx, you get big gx plus b. But the a and b are constant. So that's why we write py left hand side as a title, gx plus c, and c is b minus a. So your final answer must have one constant only, because this is first order. So now the thing is how to find C. So this is the challenge. You look at the Euler method, there is no C. When you solve the first order numerically, you already given the initial condition. This is the thing that we are going to study today, solving the separable with initial condition. But for the chapter 5, finance different method, you have initial condition plus with the boundary condition, because it is in a 3-dimension problem. So you have the heat equation depend on x and t. So you have boundary condition and then initial condition. But for ODE, you only have initial condition. This is the difference between chapter 1 to 3, even Laplace equation. Laplace equation, very strict. Without initial condition, you cannot start. So Laplace differential equation, the Laplace method, is also can be used to verify the first order. Of course, Laplace equation, Laplace transform is very useful, chapter 3, to solve a non-homogeneous differential equation. Now, you look at this example. Okay, if any question, please stop me. So if any question, please stop me so that everyone understood very well. So slide number 10, yeah? So this is how you solve analytically. Later on, we will solve this numerically with another example. dy dx equals to y squared multiplied by e power 3x. First, you must confirm that this is separable. Yeah, you must know this is separable. That is the first thing. So this y squared, you must bring left hand side. That is the idea. Y squared, 1 over y squared, you write 1 y power minus 2 dy. Because 1 over y squared, you cannot integrate. You must put y power minus 2, then we use power rule. So this step is very important. This is what we call separate the variables. Actually, separable is you form the differential equation so that step 2 we can integrate. So once you write in this form, if you cannot write this form, then you have to move on to the second one, that is linear differential equation. And then if not linear, then you move on to exact, non-exact. If not that, then you move to Bernoulli. So you have 4 different form: separable, linear, exact, and non-exact together, and the last one is Bernoulli. So in this case, this is separable. So once you separate y term x term right side, then you can integrate. So y power minus 2 dy equals to e power 3x dx. So you integrate this by using power rule. So you must be very good at integration. So integration plays a very important role in solving this type of problem. So y power minus 2 plus 1, y power minus 1 divided by minus 1. So you write minus 1 over y. So you don't write y power minus 1, because we try to avoid the negative power. We write minus 1 over y equals to 1 over 3 e power 3x. Your integration of e power 3x dx, because if you differentiate 3x, you get 3. So you divide by 1 over 3 e over 3x plus c. We always put the constant right hand side, because the y is the output, x is the input. So you can stop here, or you can write y equals to, you bring y the right hand side, or you keep y as a standalone title, as a title here. So y equals to minus 1 divided by 1 over 3 e power 3x plus c. Now, all of you take a piece of paper and pencil. We want to find the C. That is our goal. We want to find the C. So what is the C value? This is very important. So we want to find the C value. What is the C? So this is the work today we are going to do. What is C? So in order to find the C value, you have initial condition. We write like this: y 0 equals to 1. Can you find the C now? That means for first order, you must have one initial condition. So when x 0, y equals to 1. So what is your C? Yeah, you got to try now, yeah? This is exercise. You have to try and let me know what is your value C. I'm waiting. Yeah, Tan. What is your answer, Tam? Negative 1 over y equals to 1 over 3 e power 3x plus c. So what is your C? C equals to minus 4 over 3. Others? Anyone got different value? Anyone got different value? Hello? Anyone got different value? Chowjit, no sir, same answer. Okay. So your answer will be negative 1 over y equals to 1 over 3 e power 3x minus 4 over 3. You can write in this form, or you can write y equals to minus 3 divided by e power 3x minus 4. Now we want to plot the graph. So you know y is the title. You have to rearrange y. Y equals to minus 3 e power 3x minus 4. So you can plot the graph y-axis and x-axis. You can try. This is the homework. Because we want to solve this problem using Euler method also. So you can plot the graph y respect to x. Your y is output, x is the input. And then you can see the exact solution. And you compare this solution with the Euler method, Youn's method, and Runge-Kutta method. This is the exercise that you have to do on your own. So now the initial condition gives you the complete answer. So I repeat again, y equals to minus 3 divided by e power 3x minus 4. Or you can just write minus 1 over y equals to 1 over 3 e power 3x minus 4 over 3. So we gave you the initial condition in order to find the c. So you must remember, for first order, you need one initial condition. For the second order, you need two initial conditions. Two initial conditions. Any question, class, so far? Any questions? Any questions so far? Mohammed Nor Hadi? Any question, Mohammed Nor Hadi? Any questions? Sankita? Mohammed Ezri, any questions? Chia, any question? Chia? Any questions? Anything? Chia? Amirul, yeah. Any question, Amirul? Amirul, are you there? Any questions? Mohammed Aswar? Shahira, any question, Shahira? Shahira, any questions? Lee, any question, Lee? Lee, Leong. Are you there, Leong? Any question, Leong? Mohammed Ayman? Mohammed Ayman? Okay, so we will continue with the next example. So this one solve the DE. 1 plus x dy dx equals to y. You separate dy over y and then dx over 1 plus x. So in this case, you have dy over y equals to dx 1 plus x. You integrate. When you integrate this, you write like this, left hand side, right hand side. This one, 1 over y is ln y. The modular sign shows that the y cannot be negative. So y must be always positive. So ln y equals to integration of 1 over 1 plus x is ln x plus 1. Because if you differentiate 1 plus x, you get 1. You differentiate y, you get 1. So therefore, ln x plus 1, this c. Now class, you can combine this ln x plus 1 plus c by writing c as ln d. Ln d. Write c as ln d. Then you straight away you get this one. Y equals to dx plus 1. Because the e power c becomes d. So you can remove the c. It's up to you. So the c is ln d. So in the end, you don't want to write the modulus. You write the answer y equals to dx plus 1. Y equals to dx plus 1. Any question here? Any question, class? Any questions? Any question, class? Any question, class? Yeah, any questions? All right. If we don't change to lon can, yeah, it's up to you. If you don't change, it's okay. Yes, you can try now. Because if you change lon, so easy to write. Ln y equals to, this is simplicity. Okay, I write, yeah, ln x plus 1 plus ln t, like this. If I write like this, then easy for me to write y equals to nice, like this. X plus 1 and then d, like this. Because right hand side, the ln multiplication become addition. So if you don't change also can, but this is the idea. So the creativity is like this. Now, you want to find the value d now. You can try C also. So if you want to find d, we are giving the initial condition. Y 1 equals to 1. So find the value d. Okay, find the value d. Yeah. When y1, x1, what is your d? Yeah. Can anyone answer your d? What is your d? This is the initial condition. We gave you the initial condition so that you can find the value d. If you use C also can. Yeah, thumb. D equals to half. Yes. Yes. So now you substitute back. Your solution is y equals to d of 0.5 multiplied by x plus 1. Okay. So you can plot the graph now. Can you plot the graph? This is further investigation, because later on, if you solve this problem using numerical method, Euler, Yunus, Rangikota, you can compare the solution. So what is the shape of this graph, class? You can plot y equals to x over 2 plus half, or 0.5 multiplied by x plus 1. So when x 0, y is 0.5. When y 0, x is minus 0.5. So what is this graph, class? What is the shape of graph? How does the graph look like? So you take a piece of paper, pencil, you draw the graph. Just sketch. Yeah, sketch will do. Anyone? Yeah, this is the final output, class, for engineering student. This is very important. We want to investigate the final result. How does the shape of output looks like? So anyone? Yeah, Tom. What is the graph? How does the graph look like? Yes? Yeah, you can answer verbally also. Positive slope with intercept at y equals to 2 or half. When x 0, y is half, not 2. Yeah, it is a straight line. It is a line, right? It is a line. Straight line. Yeah. Y equals to 0.5. When x 0, your y is, you draw now, 0.5, half. When x 0, y 0.5. When y 0, y equals to 0, x equals to minus 0.5. So it cuts x-axis and y-axis. So it is straight line. S-T-R-A. Straight line. Draw the graph now. It is a straight line. Cuts y-axis at 0 to 0 half and cuts x-axis at minus half 0. That is the meaning. Straight line. Any question, class? This is what we want to investigate today, the behavior of output. So any questions? Mohammed Noor Hadi. Mohammed Noor Hadi. Any questions? Yeah, Lee. Any question, Lee? Lee Yong. Any questions? Any question, class, on this graph? How to plot the graph? How to plot the Y output respect to X input? Yeah, Lee. Mohammed Ayman. Any question, Mohammed Ayman? Shahira. So, Shahira, any questions? Mohammed Aswar, any question? Amirul Firdaus. Amirul Firdaus, any questions? Amirul Firdaus, any questions? Okay, so you already draw the graph. So you no need to put all the points. You put 2 points and then you draw the straight line. So the output is a straight line. So later on you will see a different shape. Now we move on to this example. So this one is the exercise. So we are going to solve now. Solve dy dx minus x over y equals to 3 when x 4. So you read this as a initial condition. You see this problem complete. Y4 equals 3, meaning y equals to 3 when x is 4. You must understand, yeah? This initial condition is a very simple form. But what is the meaning of this is, when x is 4, y is 3. So you want to solve this ODE. It can be solved by altogether 4 methods. One method is analytically by using separable. The other 3 methods you can use Euler, Yoon's method, and then Runge-Kutta numerically. So you can plot all these 4 graphs, and then try to investigate which method is the best. Of course, this analytical method is precise, so it is 100% is accurate. So you can compare the accuracy of numerical method. How good is Euler? What is the percentage of error? And then what is the percentage of error for Yoon's method? And then what is the percentage of error for Runge-Kutta? Now we solve this. Dy dx equals to minus x over y. Y4 equals 3. So you bring y left hand side. You have y dy equals to minus x dx. So you integrate, yeah? If you integrate y dy, you get y squared over 2 equals to minus x squared over 2 plus c. Write down, yeah? Write down. You got to do now. This is instant on the spot exercise, yeah? So you have to do. So you answer y squared over 2 equals to minus x squared over 2 plus c. Now, how to find c? So you substitute y equals to 3. So left hand side is 3 squared, 9 over 2 equals to minus x squared over 2, x is 4. So 4 squared, 16 over 2 plus c. So your c equals to 9 plus 16 over 2. So what is your c? So can anyone give the value of c? C equals to what? C equals to 25 over 2. Okay, good. Anyone else? Anybody got different value? Anyone got different value? Anyone got different value for C? Okay. So therefore, your final answer will be y squared over 2 equals to minus x squared over 2 plus 25 over 2. Now, we want to simplify this equation. So you have y squared equals to minus x squared plus 25. Simplify, yeah? Y squared equals to minus x squared plus 25. Therefore, you rearrange the equation. you will have x squared plus y squared equals to 25. So what is this equation? Can you draw, sketch? X squared plus y squared equals to 25. So what is this equation, class? What is the shape? Anyone? This is a very famous equation. X squared plus y squared. Circle, yeah. So can you sketch the circle? What is the radius? What is the radius of the circle? Yes. Radius is 5, yeah. So this circle centered at 0, 0, 0, 0, and your radius is 5. So can you draw now? Draw, sketch. Can you draw or sketch? Can you sketch? Let me know. Can you sketch the circle? So x squared plus y squared equals, so you no need to write y. This is the shape. So all the points on the circle is the solution for this ordinary differential equations. Yeah, can you sketch the circle? Mohammad Nor Hadi, can you sketch the circle? Yeah, you have to respond. Yeah, this is two ways. Yeah, not one way. Yeah, two ways. So you got to respond. Otherwise, we do not know what is happening over there with you. So you got to respond. Yeah, answer please. Can you sketch the circle? Rough sketch. Hello? Wen Kan? Can you sketch the circle? Wen Kan? Wen Kan, can you sketch the circle? Tam, can you sketch? Chia, can you sketch the circle? Chia Cheng. Amirul, can you sketch the circle on your paper using pencil and paper? Amirul? Are you there, Amirul? Yeah, Lee, can you sketch? So you can compare the solution with the Euler method and Yun's method and Rangi-Kota. Yeah, Mohammed Ayman, can you sketch the curve? Hello? Please answer, yeah? Can you sketch the curve? Can you answer, please? Ojit. So you got to sketch the curve and then you compare with the Euler method and then Yun's method and Rangi-Kota method. Write down, yeah? So you can plot all this curve in one graph or different graphs is up to you. So if you sketch in one graph, then you can see the differences. So this is very important. Now, example 4. So example 4, you must have full information, yeah? So the information here is solve y cos x dy dx equals to e power y sine 2x. Y0, 0. That means when x 0, y 0. That is the meaning. Yeah. When x 0, y 0. So now, if you want to solve this, y cos x dy dx e power y sine 2x, this sine 2x, we have to use the trigonometric formula. You simplify. Sine 2x, you write as 2 sine x cos x. Sine 2x, you write 2 sine x cos x. So therefore, the left-hand side, y divided by e power y dy equals to the right-hand side 2 sine x cos x divided by cos x. You have 2 sine x dx. Now the left-hand side, y divided by e power y, you write as y power e y multiplied by e power minus y dy equals to 2 sine x dx. Because the left hand side, you must write y e power minus y dy. This one involves integration by parts. So if you use integration by parts, you will get y e power minus y dy. You use the formula integration u dv equals to uv minus integration v du. So you take u as y and dv as e minus y dy. So you will get uv minus y e power minus y minus integration of v minus ey dy. Now, minus y e power minus y minus e power minus y plus c. Okay, plus c. But the c you no need to write here because we put right hand side. So your answer will be minus y e power minus y minus e power minus y equals to minus integration of sine is minus 2 cos x plus c. Now you find your c. Okay. In order to find c, you must put x0, y0. So y0 minus 0 e power minus 0 minus e power y0 equals to minus 2 cos 0, 1 plus c. So the left hand side is minus 1 minus 2 plus c. So your c is 2 minus 1, 1. Now your final answer will be minus y e power minus y minus e power minus y minus 2 cos x plus c equals to 1. So you can simplify this. E power minus y minus outside y plus 1 equals to minus 2 cos x plus 1. So in this case, if you want to remove the minus sign, you have e power minus y plus 1 equals to 2 cos x minus 1. So your final answer will be y plus 1 divided by e power y 2 cos x minus 1. In this case, you see it is very hard to write y as a title. And we do not know the shape. So you have to put x, you find y. In this case, it's very hard for you to plot the graph. So you must remember, yeah? So in this case, if you want to plot the graph, it's very hard because your final answer is y plus 1 divided by e power y equals to 2 cos x minus 1. So this is called implicit function. Implicit meaning you cannot write y as standalone in terms of x. So if you want to plot this graph, it's not easy. So you know x is input and y is the output. But you have y plus 1 divided by e power y. And this is one of the problem for the analytical method. So this type of problem can be solved by using Euler method. In Euler method, you can plot the graph for each point, x naught, y naught, x1, y1, x2, y2, x3, y3, and so on. But still, this can be plot. We can plot the graph by using computer programming softwares. So manually, it will be very difficult. So that is the difficulty of doing manually for this function. Any question, class? So the answer is y plus 1 divided by e power y because we don't want to write minus e power y. We try to avoid minus power. So y plus 1 divided by e power y. So the final answer will be y plus 1 divided by e power y, e power y equals to 2 cos x minus 1. So this is the answer. Y plus 1 divided by e power y equals to 2 cos x minus 1. Now you can test the initial condition when x0, y 0. So when x0, y 0, the left-hand side is 1, the right-hand side is 1. Any question, class? So you got to reply, otherwise you will not be able to do this completely. Now we are solving complete, we are solving this very comprehensively. That means with the totality, everything. So whatever we miss throughout the semester in the past, we cover within this short time. Yeah. So you may say, can I write y equals to? It's very hard because you have e power y. Even if you want to simplify, you can write y plus 1 equals to e power y 2 cos x minus 1. Like this also can. Y plus 1 equals to e power y. But the y term goes to the right-hand side. So we don't want to write y term on right-hand side. We want to write all y term left-hand side, all x term right-hand side. This is the way we want to put the final solution. It is very complicated function. One must remember, yeah, this is very complicated function. We call implicit function, not explicit. Explicit is what you saw just now. Why? Like the circle is not that difficult. Just now we have y equals to x over 2 plus half. That is explicit. Explicit is very easy, but this is implicit. You must know the difference between explicit and implicit. But there is some exceptional. X squared y squared equals to 25. It is implicit, but the shape of the graph is well known. It is a circle. But here you cannot predict. This one is not circle, not straight line. So this is a very complicated nonlinear curve. We say nonlinear, nonlinear curve. C-U-R-V-E. C-U-R-V-E. Nonlinear curve. So you got to plot this using any computer programming software, such as C++ or MATLAB or other softwares like Python and so on. People are now doing using Python and so on, or any other programming, because it's very difficult to plot the graph. So now we are focusing on how to plot the graph, because we want to compare with the numerical method. So this is analytical method. So any question, class, so far? Because this is the last slide for the separable. Any questions on separable? So you can try any other problems just for exercise. We hope this is sufficient for you to try other problems. So any question on this? Any question, class? Hello? All right. Tom is very active, yeah? What about others? Others, any questions? Muhammad Nabil? Amirul. Okay, Amirul is very active. All right. Now you see, we don't have a break. You see 4.1. Can you see 4.1? 4.1, yeah? Yeah. So you may wonder, why is it 4.1? So you may wonder, why 4.1? This is the relationship between chapter 1 and chapter 4. Today's lecture is about chapter 1 up to chapter 5, but we don't have time to do chapter 5. We already spent a lot of time in chapter 5. So this chapter 1, very important, because in chapter 4, you studied 3 methods. So if you see the slide, Euler's method, Yoon's method, fourth order Runge-Kutta method. Little bit on the philosophy of these methods, and then the philosophy of chapter 1. Chapter 1 and chapter 4, we are still solving first order differential equation. So the difference is, the chapter 1, we call it as analytical method. Analytical method. So that is the point, yeah? Chapter 1, philosophy is, chapter 1 is analytical methods. Okay? Chapter 4, numerical method. So what is the advantages, disadvantages? So the analytical method is to say good or bad, it must come from your own experience, your knowledge, experience. But just to give you an idea, to the best of our knowledge, chapter 1, for example, the first order that you solved just now, you must have initial condition. Without initial condition, you cannot solve the problem successfully. So we need initial condition. So that is the problem. This initial condition will be given by the expert. Initial condition. You cannot create unless you ask to do so. Initial condition is a must. Write down, yeah, for chapter 1. For chapter 4, initial condition, it's already given. It must be given. Chapter 4. So we are doing comparative studies now. Later on, if you want to justify the solution for the numerical methods, let's say they don't want to tell any name. You solve the first order using any numerical methods. So you have 3 options. Euler, Yunes, and Runge-Kutta. So you can pick any of these 3 methods and you can compare among themselves, or you can compare with the exact or accurate method, precise method. Precise method is the one we solved just now using separable method. So later on you will see how we can compare this solution with the exact method. So 4.1, the title is Euler's method. Why we select Euler's method? This is the basic foundation for all other methods. The question arises how the Yunes method was discovered, developed. Is from Euler's method, extended and then enhanced version. What about 4th order Runge-Kutta? Also same. It's very advanced method of Euler's. It already gone through 4 stages. 1st order, 2nd order, 3rd order, 4th order. We pick 4th order because this is the best among the Runge-Kutta method. Among the Runge-Kutta means among 1st, 2nd, 3rd, and 4th. So the 4.3 is one of the very powerful method, but we cannot guarantee all these 3 method, numerical method will give you 100% accurate solution. That is not assured. You got to try and you got to find the error. So today we are talking about the chapter 1, the analytical solution and numerical solution as in chapter 4, and we want to find the error. So we just pick Euler's method today. Now, the Euler's method, straight we are going to the point, is developed from Taylor series to solve this equation. This equation dy dx equals to fxy not necessarily will be linear, separable, or exact, or non-exact, or Bernoulli. No, it will be in any form, but first order. So this is the advantage. So you study Euler's method to solve all that 4 types in chapter 1. Chapter 1, just now we picked separable, but underneath you saw linear using integrating factor. And after that, exact, non-exact. And then last one is Bernoulli. Even Bernoulli, if you can write in this form, dy dx equals fxy, you can solve Bernoulli using Euler's method. Numerically, Bernoulli can be solved analytically by using the linear method. You reduce Bernoulli into linear and then find the integrating factor by using substitution. So that is the process you got to do. But Euler's method, no. You directly use the Taylor equation, this one. What is your y? Y is your output, equals to y x naught plus h y dash x naught. So what is x naught? What is h? What is y dash? Y dash is your fx naught, y naught. X naught, y naught. This is the problem, class. Normally, you are not aware. You are not aware about the x naught, y naught. So we have to give importance. The x naught, y naught is called initial values for input, output. It will be like initial condition, but we don't say it initial condition here. The terminologies are different. The way you say is different. In this case, you don't use dy dx. You use y dash, and y dash x naught, you must substitute f x naught y naught. So it solves this ODE directly, very direct. Straight away get the output. So that's why the numerical method is better than the analytical method. But numerical method such as Yoon's Rangi Kota has lot of iteration. That is the lengthier part, not the output. So you calculation of the output is time consuming, but that is unavoidable. And also that can be overcome by computer programming by using the softwares. And that is you can use for your project assignment, for your further studies, you can develop the software using the programming. So now the general equation to solve this ODE is this one. So you must know the subscript. We want to explain to you. This Euler method is one step. Y x subscript I plus 1 equals to y x subscript I plus h f x subscript I, y subscript I. Many of you will be wondering why the subscript is missing when you solve the problem. It is not missing, but we forget to write. That's all. So I plus 1 meaning the next x. X subscript I is the current one. Xi, yi, the current one. So you put yxi, h is the step size, fxi, yi, you predict the next output. Next output for next input. So if I put I0, yx naught plus h fx naught y naught, yx1. So that yx1 become y1. So you start with y naught, you predict y1. So you create the table, draw the table. You must draw the table now. Very important class. Draw the table. Draw the table. For Euler, you need the table. So this is two columns. Two columns table. So what is the first column? First column, you put xi, and the second column, yi. So you can create the x values and y values. A few iterations, at least 3 or 4 iterations. More iteration, much more better. So x naught, y naught, first row. Second row, x1, y1. Third row, x2, y2, x3, y3, x4, y4, like that. Okay, 2 columns table, one for xi input, one for yi, x subscript I, y subscript I. So this table, once you have the table, then you plot the graph. GRAPH. Yeah. Rasha, if the question asks to compare the Euler method with the exact solution given outside, do we need to differentiate the exact solution first before we compare it? No, where you wait, we will explain. You have to solve first by numerical first, then exact. Do we need to differentiate the exact solution first before we compare it? Like tutorial 4. Yeah, tutorial 4 is up to you. We are going to show you. Wait. We are going to show you. Wait. Wait, please. So wait for this finish first. So H is B minus A divided by N. And what is A, what is B? Try to understand this first. I know all of you knew already. This is the final revision. After this, no more already. So if you want to ask question, you can ask me about this now. So H is B minus A divided by N. A lower bound, B upper bound must be given. Otherwise, you cannot solve. N depends. N number of interval you can calculate or it will be given. And H also you can find like this. This is very important class. H equals to Xi plus 1 minus Xi. So you put I0, X1 minus X0. You put I1, X2 minus X1. You put I2, X3 minus X2. So H is the step size. And this method is called Euler-Cauchy, name of the person, and point slope because it involves dy dx. You don't write dy dx. You write fxy, fxi, yi. Now we want to answer your question. Who is that? Farasha, you just wait. We want to answer your question by solving, not by just talking. Yeah. So you solve. I know you solved the tutorial problem. Look at this graph. This is what you're asking. Yeah, good question. Yeah. So Parasha, yeah, you look this graph. So we are answering your question. This one, Y output. This one, X input. This one, Xi. This is Xi plus 1. So you have H. Normally you start with X naught. X naught, this fellow is Y naught. This one is Y naught. X naught, Y naught. This one, X1, this is Y1 here. Like that. So the exact value separable is this one. Separable, integrating factor, linear, exact, non-exact, Bernoulli. Chapter 1 is this one, true, precise, very accurate, 100%. This one is predicted one is Euler, number 1. Number 2, Yuns. Number 3 is Rangikuta. This is predicted one. But the true can be higher, predicted can be lower, depend. But this keyword is error. This is the question now. So what is error? Error is equals to the modulus of true minus predicted divided by true multiplied by 100%. Write down now, yeah? Error equals to modulus, the length, T minus P divided by t multiplied by 100%. We want to calculate this, class. We want to calculate this. We want to show you. There is a huge philosophy involved here, but we are not going to into the philosophy of the methodologies, concepts, theories. We want to show you by solving the problem. But we will give you some valuable ideas, suggestions. Now, we pick this example to show numerically as well as analytically. You see this problem, full information, but the method need not be Euler method. We can say use any numerical method. Use any numerical method or use numerical method. So in that case, whether Euler or Yuns or Rangi-Kota is immaterial. Now you already knew three methods. You can solve this problem using three methods. It's okay. And you compare among themselves. But that is one thing. But comparison among all the numerical method, you will not be able to find the exact error because among themselves only. So we can use the separable method, which is the true value for the dy dx for x squared. Now, you want to solve this at x equals to 2. That means from x1 to x2 with n1. That means 2 minus 1, 1. That is n. Given y1, 1. You see, this is given. This is the problem, class. In numerical method, this will be always given. Otherwise, you cannot start the iteration. So you already have x naught equals to 1, y naught equals to 1. x1 equals to 2, y1 you want to find. That is the table now. You create the table, 2-column table now, xi, yi on the top. And then first row, x naught 1, y naught 1. And then after that, second row, x1 equals to 1. x1 equals to 2. What is y1? That is the question. But now, answering your question, you said first you want to solve, what is that? Your question is, do we need to differentiate the exact solution first before we compare it? You can solve this exact method first. Okay. Your question is not clear, but to my understanding, dy dx equals to 4x squared dx. Write down, yeah? Now, you integrate dy, you get y equals to 4 integrate x squared x cubed over 3 plus c. So now you want to find c. When x1, y1. So 1 equals to 4 over 3 plus c. So c equivalent to 1 minus 4 over 3. So your c is minus 1 over 3. So the exact solution, y equivalent to 4 over 3 x cubed minus 1 over 3. You got it, class? Y equals to 4 over 3 x cubed minus 1 over 3. That is the exact. You keep that side. Later on, we will compare. When we substitute x equals to 2, you will get y is 10, 1 over 3. Okay? That is analytical solution. Now, the numerical solution is like this. You must recall back this. This is very famous, one step only. Direct solve. The rest are just explanation. But the equation is one only. Doesn't involve integration at all. That is totally you are in a different world. This is what we call numerical world. y x subscript I plus 1 equals to y x subscript I plus hf x subscript I y subscript I. Now, this information all is given and you can find yourself. Y1 equals to 1. If you want to find step size, is hb minus a divided by n, all given, h is 1. When x naught, y naught, this is the problem. X naught, y naught. When x1, y1, you must put inside 4, 1 squared, 4. You need this value in order to plug inside here. You must know what is x naught, y naught. This is x naught, y naught, given. Now, y x naught is this one. X naught is 1, y is 1. So now we calculate. We do one iteration only because they ask you to find x2. What is your y? So when x2, your y is y, x naught is 1 plus h1, f x naught, y naught, 1, 1. So 1 plus 4 is 5. So when x equals to 2, y is 5. So you fill up the table. If they ask you to find x3, you find y, y2. X2, 3, y2, what is the value? And then x3 is 4. What is y3? And so on. But in this case, we stop here because you asked to find at x equals to 2. So our answer is 5. That's all. Now class, when x2, y5. This is Euler's method. Now the exact method, you calculate now. Y equals to 4 over 3, x is 2. So 2 power 3, 8. 8 multiply 4, 32 divided by 3 minus 1 over 3. So your y is 31 over 3. That is 10, 1 over 3. So now you can calculate the error. So can you calculate the error now? Can you calculate the error? Calculate the error now. Please calculate the error. So the true value at x equals to 2 is 31 over 3 minus the predicted value at x equals to 2 is 5. So 31 over 3 minus 5 divided by 31 over 3 multiplied by 100%. So what is your answer? Yeah, 51.6%. So the question is, okay, correct. So the question is, are you happy with this answer? As an engineering student, this is something to do with the experience, also plus with your knowledge. Is this percentage is good? Question. Is this percentage is good? 51.6%. Is this good? So the question is, so is this a good error? So class, normally we want the percentage error and 10% to 20% in this range, if not less. So this is your target. Maybe you want error 5%. Okay, this is the outstanding one. If you want 5%, this is excellent one. So if you want 5%, this will be a very hard job now. challenge. Okay, now we want to solve this problem. Want to solve this problem. A problem of error. So class, there are few ways to overcome this matter. First thing you see, the h, what you have done is equals to 1. So we have to reduce the h. But this is not guarantee. Reduce the h. So you go home, try h equals to 0.5 first. We are talking about Euler method, yeah? Try h 0.5. Home exercise, yeah? You go home and try. Now, if your percentage is still very high, then you go for h equals to 0.25. So when h 0.5, your x0 1, x1 1.5, x2 2. When your h is 0.25, your x0 is 1, x1 1 to 1.25, x2 1.50, x3 1.75, x4 is 2. So you got to do 4 iteration. If h 0.25 also not give you the percentage exact, the error is what you want. The error is up to you. Or in the problem, they will give you what percentage error was you asked to reach that target, less than what percentage. So if h 0.25 also not working, then you go for h 0.1. But this one, you have to do 9 iteration. 0.1, 0.1.1. You start with 1, you reach 2 by 1, 1.1, 1.2, x value, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, then 2.0. So 9 iteration. So it doesn't mean that by reducing the age, you are guaranteed to get the accurate answer. No, it may not work. It may not work because depend on the complexity of the problem. In this case, there is a possibility that you may not reach the error 10 to 20% or 5%. The reason is, for the simple reason, the Euler method may not work very well. That this is the possibility, yeah, the possibility. But the reality is, you got to try. You got to try. You work out, because h 0.1 is not easy. You have to do 9 times. So time consuming. So you have to sacrifice the time in order to get accurate result, accurate output. So we are very much concerned about output. So the advantage of doing the 9 iteration, you can plot the graph. So you go home, you plot the graph. You try for h 0.1 and 1, and then plot the graph. So once you have the table, it's easy to plot the graph, and then you can compare with the graph y equals to 4 over 3 x cubed minus 1 over 3, the exact solution. somebody asks whether you can do it within one graph with the different age and then with the exact solution. It's up to you. Okay. So now, just now, if you try very small age, you hope to get very small error. But if that doesn't work, then the next possibility is you must try with Rangi-Kutta method. Rangi-Kutta, RK method. You must try with the Yoon's, HE, Yoon's method or Rangi-Kutta method, RK method. RK method is fourth order. So that is the final one. So the final one is about changing the method. You don't worry about the precise solution. The precise solution is there. And the error calculation is well defined. T minus P, take the modulus, divide by T, multiply by 100%. So this is a very good question, very adventurous problem, because you got 51.6% error. So you can try solve the same problem using Yoon's method, number one, using Rangi-Kutta method with the step size H1 or H0.1, H0.5 or H0.25, or H0.1. But somebody told us that Rangi-Kutta method involves a lot of iteration. That is how you compensate with the analytical method. You see, analytical method, you have to follow the steps, you have to follow the integration and make sure you find the C. So that is the nature of the analytical method. But in numerical method, at the moment, you must make sure your calculator works very well, because that is the one you're going to use for the next EA session. So if you find that the error is too high and they ask you to improve the error, minimize the error, the question here is, the most challenging question is how to minimize the error. Within the limitation, that means within the three methods, Rangi-Kutta, Yoon's, and Euler, you got to find the solution. But these three methods is insufficient. We cannot guarantee that Rangi-Kutta method will give you 100% accuracy. This is maybe not possible. Okay. So that is your home exercise. And then the other problems you can try. But today's lecture is, this is what we want to do today. So any question, class? Yeah, Shahira. Yeah, Farasha. Any question, Farasha, now? Yeah, now we open for question and answer session. So we don't have anything anymore, but you can ask all chapter 1 up to chapter 5 generally. How many questions for EA, sir? Yeah, Sunil did. If not mistaken, 3 or 4. Chapter 1, 1. Chapter 2, 1. 4, I think, 4. If I'm not mistaken. First order, analytically. And second order, constant coefficient. Non-homogeneous. Euler, Rangi-Kutta, and Yoon's 1. And finance different method. Finance different method, you have heat equation, the PDE, solved by 3 method, explicit, implicit, Crank-Nicholson. I think 4. Yes, Suniljit. How are you, Suniljit? Suniljit, how are you? No problem. No problem. Take it easy. Yeah, so you have to revise first order. Maybe the method is not given because the nature of the EA is very general. It's up to you which method you select. But you study, you revise everything. You revise first order. You know, first order you have separable, linear, exact, non-exact, and then Bernoulli. Laplace is not separate. It's together with chapter 2. Because chapter 2 undetermined coefficient, the Wronskian, and then Laplace is in one, embedded. It's up to you. You can solve the what we call constant coefficient, non-homogeneous method using undetermined coefficient. Wronskian depend on the non-homogeneous part. And then if possible, you can solve using Laplace. This is option class, option only. You are not asked to use any particular method. You select the method. You select the method and then you justify. The most important thing is how to justify, how you justify your answer. And then you can write some comments if you want. Just write some comments. How do you find this method? So basically, you have 3-4 methods to solve one problem. So you do comparative studies and then make your comments and what you think about the solution, the output. Any more questions? Yeah. I refer to all the lecture notes. I think the lecture notes are sufficient for you. Of course, you can try few tutorial problems because the EA is very open. It doesn't involve any particular method. So it's up to you how you perform the EA. Yeah. Any more questions? Before we stop, and for the test 1, test 2, we are still working on it. We will upload. Not hard. Not hard. You can do it, but you must be a little bit creative. That means the information sometimes will not be clear because it's open-ended problems. So you got to fix the value on your own and then try to work it out. Because this EA is extended assignment. It's kind of assignment, not exam. Of course, replacing the exam, because exam is straightforward. Yeah, you are right. Straightforward is exam. You don't say hard. You say a little bit more on creativity. You have to be, you have creative thinking. You come out with your own way with existing methodologies. You already studied class. We can summarize these 5 chapters in a very short way, because chapter 1, 2, 3 are the numerical analytical group. They are in analytical group. Chapter 4 and 5, they are in numerical group. So you put it these two. And then there is a relationship. That's why I show you the chapter 1 and chapter 4, how they are related. So this is one way how you can do the innovation. You try to verify the percentage of error with the analytical method. I'm not saying that this is possible for every problem. No. That is the most challenging part is the chapter 5. There is no analytical solution that you studied. If you want to study the solving the PDE using analytically, that is different subject. So totally it is off. We 100% we solve chapter 5 numerically. So there is no way like what you did just now, true minus P divided by true multiply 100% doesn't work because you don't have true value for the chapter 5. Chapter 5, in a way, it stands alone. Even having said that chapter 4 and 5 in one group, because under the umbrella of numerical methods, but chapter 5, you don't have the analytical method of solving at the moment, but that will be you study in the future. Yes, there is analytical method to solve the heat conduction equation, the partial differential equation. But we already, in the beginning, we already mentioned finance difference method. So it's already fixed. Finance difference method is 100% numerical method. So you have to discretize, discretize the values using the iteration. That's why you have the capital T, and then you do 2 or 3 iteration and find the error. Yes, you can find the error, but within the iteration. So that is the limitation of the chapter 5. That which we show you the chapter 4, that is different, very powerful, because you're comparing with the analytical method, which cannot be done for chapter 5. Yeah. Any more question, class? Before we stop. Not hard, but you can try. You can work it out. You can work it out. Try your level best. Is it okay, Suniljit? Yeah, it is open-ended problem. It's very hard to say. You have to do by using your knowledge to the best of your knowledge. To the best. Sorry. We say philosophically to the best of your knowledge. This is very highest philosophy class. A word of wisdom, yeah. Word of wisdom, yeah. So, to the best of your knowledge, of course, experience you don't have much. It's very hard to cover the 5 chapter within 12 weeks, but we tried our best. We successfully completed the 12 weeks lecture. Of course, we have a big problem, internet problem here and there. And most of you submitted your assignment, tests 1, test 2 via internet, emails. So we will look into that. We will compensate. Those of you missed test 1, test 2, we will compensate. Quiz 1, quiz 2, we will compensate. Assignment remain as it is. So third week of December, we will upload your coursework mark. Third week, yeah. So when you see your coursework mark, if there is any discrepancies, any missing, please email me reminder. Email me. I think most possibly on the 13th December. 13 December, the coursework mark will be out because we are still in the process of handling test 1 and test 2. So any question, class? Thank you, Suniljit. Thank you for your questions. Well done, sir. Okay, any more? Any more questions? Mohammed Noor Hadi? Mohammed Noor Hadi? You are welcome. You are most welcome. Welcome. I wish you all the best. Okay, so shall we stop here? All the best. Have a wonderful weekend.